What's happening, Taylor Tots, and today we have another new video. This is going to be the first of 3 uploads today to make up for some videos being a little bit slow uploading. I decided just to remake them, just to have them be a little bit better for that. Now you can see that I have something in front of me that has a lot of lines, a lot of color to it, a lot of different arrows. And one of the things I just wanted to first off and start with is this is not a scary thing. You guys have heard of phases before. And we know that phases, right, these are going to be solids, liquids, and gases. And this is actually called a phase diagram, which kind of helps put us and put everyone on the same page about what conditions will a certain material be a solid, be a liquid, or in this bottom region, a gas. And that's really what this is for. Specifically, this one's for water. This is the famous one. So under these conditions, if you're over here, you're going to be a solid. If you're over here, you're going to be liquid. And if you're over here, you're going to be gas. And that's really all that this is saying. Now, I really haven't talked too much about the axes yet. So what happens is we have temperature as our x-axis and pressure is our y-axis. And what this really occurs is if you have a given temperature, say cold over here, hot over there, or pressure, this is low, this will be high, what state of matter will water be in? So for example, if you have a really low temperature and a really high pressure, it should be a solid, right? Because if your particles are super, super close together, not moving a lot, and you're squeezing them a lot, it's going to be a solid. Gases would be the same way. If you have a really high temperature and a low pressure, which is what we talked about being an ideal gas, well, obviously then it's going to stay a gas. So if you really think about this, this is pretty intuitive, and of course liquid's in the middle. So you really kind of got to just think to yourself, hey, if you're going to have a low temp, start to squeeze it a little bit, you're going to be in the solid range. Gases are really, really high, and you can see from this region, like this whole area is the gas region. It makes a lot of sense. A few points I wanted just to point out here. Just kind of for funsies, if you're looking up these, there's something called a critical point. That is a zone where around this border, and this is not really that important, you start to get a material that's called a supercritical fluid. It can be a gas and a liquid kind of at the same time. When we come back, I'll definitely show you a cool video of that. And something that I'm definitely 100% going to show you a video on is what happens at this point right here. I'll let you think about that for a second. Well, you see how it's touching all 3 regions. That's called the triple point, and that's when you're going to have a solid, liquid, and gas at the same time. Okay, I will show you guys a video on that. I'm going to link it to the description below, probably on this one too. So I'll link 2 links to the video. Kind of check that out. And that's really what this diagram is. That's a solid, that's a liquid, that's a gas. That's really all there is to it. But I wanted to bring my attention back to these arrows. And I put a multiple set of arrows because I want you to know it doesn't matter how it happens. If you're going from solid to liquid, liquid to solid, solid to gas, gas to solid, liquid to gas, or gas to liquid, those are the phase changes. And what I've done is, deposition and sublimation are these 2 right here. That's going from a solid to a gas. Again, I'll show you a video of that, and I'll attach it underneath. Not really something that we're worried about too much. Dry ice does this. It's a really, really big one that does it. Iodine does it a little bit, but that's disputed still to this day. But I'll definitely show you a link of that. These are the ones I expect you to know. I do expect that you know what the blue arrows represent, what red arrows represent, what the purple and green arrows represent. And I think we know what those are. If you cross the line any way going this way, so I'm blue right now, any way you cross it, can cross it here, here, anytime you're crossing this line represents where substances are going to go from a solid liquid or liquid to solid. Which means, as you know, as you go this way, you're going to melt. Okay? If you're going this way, the red, anytime you're going from anywhere over here to this, it could be from here to here, it could be from here to here, it could be any combination crossing this line, liquid to solid, we call that freezing. What do you guys think the purple one is? Think about it for a little bit. What do we call that? This is the harder one. And the answer is 3, 2, 1. Condensation. Green, going from liquid to gas. That one is called vaporization. Now, you guys know vaporization under 2 terms. Boiling and evaporating. Okay, both of those would count as vaporization. And like we discussed, the blue is melting and the red is freezing. So really, this is really just a review of the phase changes and how they occur. Pretty chill, nothing too scary about this. Very short worksheet on the website about this. I'm going to hover over here just for a little bit so you can kind of see that. I know you guys know those words before. Again, I'll show a video on these. These aren't as important. The big ones are the top 4. But that's really all I have for this short video. This is upload number 1 of 3, and we'll kind of go from there. See you later, Taylor Tots.